So this is the first one I've heard asked for us to go through. And this one is set up for us already in a factored form. Like this could have been given to us harder. This could have been cosine theta sine theta minus sine theta, where we had to then factor it. Since we are currently in factored form, I've got two things being multiplied together. Since they're being multiplied together, what can I do to figure out where that solution is going to be? Yeah, I can say when does this guy equal 0 and when does this guy equal 0. So I want to know when cosine theta minus 1 equals 0, just like we used to do for quadratics. Take each of our factors and set them equal to 0. And we want to know when sine of theta equals 0. So looking at our cosine guy over here, what do I need to do for this one? Add 1. So we're looking to see when... Hello, pen. Oh, it froze. Come on. Ooh, it froze hard. Ooh, it froze real hard. Come on, iPad. Wakey, wakey. Why is it trying to... Oh, it wants to fully relaunch the software. Love that. Let's try that again. There we go. That froze hard. So we want to start by adding 1 to both sides so we get our cosine all by itself. Cosine theta equals 1. So then what we're doing is we're thinking through our unit circle. When in doubt, think about it in terms of the unit circle. Where do we get cosine equal to 1? What angles? Yeah, so the only option on this guy is for 0. How do we list out our coterminals though? Because this is our finding all solutions. So our theta has to be 0 or I was going to say, because where do we get our 2 pi n? Because this is our guy that equals 0. Oh, that is really hard to see. Let me make that thicker. This one. But we also need all of our coterminal angles. So we need to include that plus 2 pi n to include all those coterminal angles. Because that would be true for 0. It would also be true for 2 pi. It would also be true for 4 pi. It would also be true for 6 pi, 8 pi. I could keep going round and around and around. Yes, dear?
So it's only like in the unit circle when it specifically gives us that. Like,
if it tells us it's on the interval, that's when we're going to have our finite list. If we're finding all possible solutions, we need to include all coterminals as well. And this was in the section that said find all solutions. So that's why we're doing the thing. So then our other piece we have is our sine of theta equals 0. Where do we get sine of 0? So our theta would need to equal, as I say, we actually get 2 options on this one.
0.
Yeah, so we're going to have our 0 and our pi. We've already got 0 included, so we still know it's going to be 0 plus 2 pi n. And we can have our pi plus 2 pi n. And the 2 of them that are exactly the same. So this guy and this guy are exactly the same. So I don't need to write it twice. And I'm 100% happy if you guys write your answer like this separated. We have our theta equals 0 plus 2 pi n and pi plus 2 pi n.
Is it tangent when we just add the pi n?
Tangent and cotangent would be just pi n. Sine and cosine, because we're looking at our whole circle, we got to go the whole way around. Since tangent repeats on the semicircle, that's why we only do pi n. If you look into answer keys or look online for solutions to this, it probably just says pi n as your answer. Because if we think about it, it's our 0 and then our pi, and then every time it repeats. So it's pi, 2 pi, 3 pi, 4 pi. So if you look online or if you photo math it or did something like that, it probably just says pi n. It means the same thing as 0 plus 2 pi n and pi plus 2 pi n. And I am okay with us writing it like that because it means the same thing. And that's the way we structured it. So those are our answers. Okay. Any other ones you guys want to work through? I'm just going to put this note here because these are the same. There we go. Yes, sir. It'll say in the instructions to find all possible solutions or to find on the interval. Yes. And this one just had the instructions of all solutions. Yeah, so this one had in the instructions to find all solutions. If it says find on the interval, that's when we're going to have our finite list, our limited values. Okay. What else do you guys want to look at? What's up, Jace? 34. Let's take a look at 34. On 7-2? 7-2, number 34. Let's see. 34. Oh, yeah, it's a good one. That's a good one. So this is 2 cosine squared x plus sine x equals 1. And this is another one in the find alls. So we're going to, I'll put that up here. So this is find all, not just on the unit circle. So we're finding all possible solutions. So what should we do here? You could divide by 2, but then since I need to divide absolutely everything by 2, it's going to be unpleasant. Because it would mean I would have to have sine over 2, so I'd have 1/2 sine. So you can. It's not pleasant, though. What's over 2? What you got? Yeah, let's change our cosine squared to be sine. I'd really rather us just have one trig function here. So if I want to replace this guy with sines, what's it going to be? 1 minus sine squared. We're using our cosine squared theta plus sine squared theta equals 1 trig identity. And if I subtract sine squared from both sides, we get our cosine squared theta is 1 minus sine squared. So I can replace my cosine squared with 1 minus sine squared x. And everything else is staying the same. This is not necessarily the only way through this, but honestly, I think this is the most efficient way through it. Yep, we're going to multiply that out. So let's do that. Let me grab a different blue. So we're going to have our 2 minus 2 sine squared x plus sine of x equals 1. Then what should we do? I think. You could subtract 2. It's not going to be super helpful though. I see a square and a non-squared piece of the same thing. So this is probably going to be something quadratic-esque. So let's see if we can get it equal to 0. So I see an x squared, and that's where it gives me, or my something squared, that's where we get that clue. So let's set it equal to 0, which means I'm going to subtract that one from both sides. And I'm going to scooch things around so they're in standard form. So I'm going to have my minus 2 sine squared x plus sine of x. And then we have our 2, and we're subtracting 1 from both sides. So we have plus 1. Then what should we do? Say it louder, I can't hear you with my heater. Yeah, so we could look at this and go, ew, quadratic and negative, gross. So multiply absolutely everybody by -1. We can switch that to be not negative. Totally fine. To get 2 sine squared x minus sine of x minus 1. Absolutely valid. Because we don't want to have minus in front. Ew. Then what could we do? A u substitution. What are we going to set our u equal to? Sine of x. By replacing sine of x with a u, that's going to switch this down to be 2u squared minus u minus 1 equals 0. Where can we go from there? Factor it. Whatever method you choose to factor. We have lots of choices when it comes to factoring. You can box it, you can split the middle, you can bottoms up, lots of choices. I was like on the answer key, I did show the box method version of it. Because we should wind up with factors of u minus 1 and 2u plus 1. So what do we get for our solutions for u? Yeah, so we'll get that u equals 1 for this one, and u equals -1/2. But I don't need to know what u equals, I need to know what x equals. So we got to substitute back in the thing we took out. So what we have here is we have sine of x equals 1, and sine of x equals -1/2. So what are our options for x? Where do we get sine equals 1? Pi over 2. That's where sine equals 1. How about where does sine equal -1/2? What are our options here? Say it louder. Never? Say it louder. 4 pi over 3. That's got a cosine of -1/2. Careful, careful. 7 pi over 6 has a sine of -1/2. And 11 pi over 6. If we were just looking for our values on the unit circle, those would be our guys. But we were asked to find all. So every single one of these things needs that plus 2 pi n. So I'm going to just scooch this guy over. Boop. There we go. So since we need to find all, I'm going to get, there we go. All. That's when you take our to get all those coterminals. Plus 2 pi n plus 2 pi n. So this is our answers. Those are all the places where this will be true. All the places where we're going to have solution. Okay. Good question. That's a good one. That one's a really, really common one that people get stuck on. It's really tricky sometimes to spot the factoring that goes in there. Any others? Say it again. 63? Yeah. Let's look at that one. Boop. Page. So, looking at 7-2, number 63. So this is on the interval. 0 to 2 pi. And the problem we're given for 63, that's... One second. Coca-Cola. Okay. That's our 2 tangent of t minus secant squared t equals 0. So it's that one, right? Is that the one we meant? That's the one we meant, right?
Yeah.
Okay, cool. What do we notice?
Secant squared.
And see a secant squared. So whenever we see somebody squared, we're going to think about if we have a trig identity that's going to be helpful. Whenever we got something squared, think about our trig identities. We've got our 1 plus tangent squared theta equals secant squared. So whenever we have something squared and we have a couple of different trig functions, look and see if we can get everybody to be the same piece. So I can swap my secant squared out to be 1 plus tangent squared. So I can rewrite this as my 2 tangent of t minus our 1 plus tangent squared of t. Where do I need to go from there? Distribute that minus sign. Absolutely right. So we need to do our 2 tangent of t minus 1 minus tangent squared. Then what should we do? You can, but that's not going to be particularly helpful. It's another quadratic type. So let's rearrange it so we're in standard form. So we've got our minus tangent squared of t, positive 2 tangent of t, minus 1. I'm just scooching things around. Ooh, they're getting small. Hang on. Multiply everything by -1 because I really don't want to have to deal with that thing being negative. Ew. So we're going to have tangent squared of t minus 2 tangent of t plus 1 because we multiply everybody by -1. Factor it. Use a U substitution. Both excellent options. I'm going to set tangent of t as a u. So we can have our u squared minus 2u plus 1. And when we factor that, what do we get as our factors? U minus 1 and u minus 1. So we're really only looking at when u equals 1, right? Those are our solutions for both of those pieces. So when does tangent of t equal 1? Mm-hmm. So our t would need to be our pi over 4. If I was writing it for all possible things, it would be that when we would have our plus pi n because we're in tangent. But since we're on our interval, we need to list out all the places on 0 to 2 pi where that is true. So our t, our angle, is going to be pi over 4 or 5 pi over 4. So this would be how we would write it if it was for all possible. These are on the interval. This is our answer. Where did I lose you? Where's tangent 1? Means my x's and y's have to be exactly the same because I would need sine and cosine to simplify down to be 1. So it would be square root of 2 over 2 over square root of 2 over 2. Think through our unit circle on those ones. The only place we're going to have tangent of 1 is going to be on our pi over 4s. If we think through these values, on this guy, we have our square root of 2 over 2, square root of 2 over 2. Because when we take that tangent, that would be 1. If we had our 3 pi over 4, we would have a tangent of negative 1. This one has tangent of 1. Okay, so tangent repeats every semicircle. So this guy and this guy have the same tangent, which is why we need to list both of them for our solutions. Yes, dear?
Why is for all solutions, is it plus pi over n instead of plus 2 pi over?
Because tangent repeats so frequently, this guy also has a tangent of 1. This guy also has a tangent of negative 1. And if we go through and find all of them, here we have our tangent sine over cosine. We would have here our tangent being 0. This one is going to be tangent undefined. This guy's tangent undefined. This guy's tangent of 0. So if we notice, and if I filled in more and more pieces, all the values we get on this half of the circle for tangent are exactly the same as what we get over here. They mirror each other. So tangent repeats on a cycle of pi, whereas for sine and cosine, we have to go all the way around to catch those pieces. Sine and cosine has to go 2 pi. Tangent, it repeats because those values are so repetitive. So with tangent and cotangent, we do pi n instead of 2 pi n. Okay. Good questions, guys. Good questions. Any other homework questions you guys want to work through? Okay, do you also have your quiz 4s if you guys would like to see those? Got those graded. So you can't have them yet because I still have some people that haven't taken it. But if you would like to see your quiz 4s, you can come and see them. That's the one you guys took last week. Have them if you want to see them. Put this there. Hey, so if you guys want to see your quiz scores, I've got let's say 7 quizzes tomorrow over what we've been doing, all the solving stuff. Yep.
Sophia asked my mom to get her ears because you know how you asked. I'm getting my 2 quizzes that are having cases in the same month. Fernanda, she's a freshman, and Sophia. So like, $100.
Okay, not bad.
She like, and I think she got me.
Bro, I would never forget what someone said.
Oh yeah.
I forgot. I don't know why. I thought it was blown. And I love my crown. Every day, every like now and then, I just wear the crown.
I've been to California twice with it.
Look at me like that. There we go. There we go.
She was looking at them. She actually lost. She was like,
And then one of them was from Mexico.
that show, by the way. I think I kind of like the show more. I wonder, like last year.
Oh, no.
But I learned what's on that one.
There you go, dear. Mm-hmm.
Oh yeah.
Oh, I think Ava was not here, so they made a couple of changes. And then Dominic, that's what Dominic was in the front by himself, and he was just doing random stuff. Yeah, in the front. And then Jerry said that they wanted to do like backflips and all that stuff, and also said no, but they said they're still doing it, so we'll see. Can you do a backflip?
Yeah.
Question. I wanna do it. I'm gonna do an aerial. I need to, like if I learn it again, I can do it, but it's because I stopped. And my splits is literally there. I can do the splits. I've been like, I'm stretching out, but I guess. No, I can't. No.
You should wrap it away.
I know there's a lot. He takes pictures every single second. Like hours. Oh my goodness. Hello. to like look. What it is.
I'm not gonna lie.
I like photographer. I like
I know.
him
And tomorrow, I just said tomorrow. Tomorrow is just gonna hit. It's gonna come.
You know what I'm saying?
Listen, these are good things that we were
Putting my
having,
appointment off.
not gonna lie, and we have an LEQ on Friday, which is crazy. I suck at those. I think those are what I'm worst at.
I think I'm good at it. It's just I don't know. This unit has been like really.
It's weird.
for
I
me.
feel like I don't even know what's going on. Like I feel like if you ask me this stuff, I know, but I wouldn't be able to tell you what we're talking about.
Right now, I would remember the and that's about it.
Right.
Is today?
I can't tell you anything else.
Is it today?
I have to be looking at my notes and everything. Like the register, I thought that was a
What is that?
massacre. No, it's about communism.
I didn't even know that was what that was. Hello?
Communism.
I need to lock into that class.
Communism.
I need to get a good grade on the LEQ.
Bro, give me
I'm studying my butt off for that.
I'm talking
There's
On
something
Thursday night.
Okay, I gotta wait for you. Come back.
I said I was gonna study on the weekend, but
I didn't even know until today that we were having that.
she told us 2 weeks ago.
Listen, he said he's to lock in. I'm not playing with him no more.
Far away. You ain't weird, but
Far away.
I mean, look close. That bag got to
I might have to
joke.